Hello. In this demonstration, I will present our functional programming mini project implemented using the Haskell programming language. The project is titled Student Marks Analyzer. The objective of this project is to read student marks from a CSV file, process the data using functional programming principles, and generate a summarized output that includes total marks, average marks, and grade classification. First, I will show the source files used in this project. I navigate to the project directory and list the files inside the circ folder. The project contains the following Haskell source files: Main.hs, DataTypes.hs, Processing.hs, Utils.hs. Each file has a specific responsibility. Main.hs is the entry point of the program. DataTypes.hs defines algebraic data types such as student, summary, and grade. Processing.hs contains pure functions for calculation. Utils.hs provides helper functions such as CSV parsing. IOHandler.hs handles file input and output. Next, I will display the input CSV file. The input file is named students.csv and is located in the data folder. This file contains student IDs, names, and marks for 3 subjects. The input file includes sample student data that will be processed by the system. Before running the program, I will check the installed Haskell compiler version. I run the command ghc-version. This confirms that the Glasgow Haskell compiler is correctly installed and available in the system. Now, I will run the program directly using runghc without using stack. I execute the command runghc -isrc src/main.hs. The isrc option specifies the location of the source files. The program reads the input CSV file, processes the data, and generates an output file. The console confirms that the input file is read successfully and the output file is generated. Next, I will display the output file. The output file is named summaries.csv and is created inside the out folder. This file contains the computed total marks, average marks, and grades for each student. The grades are assigned based on the average marks using pure functional logic. To conclude, this project demonstrates the practical use of functional programming concepts in Haskell. The system uses pure functions, algebraic data types, higher-order functions, and modular design to process real-world data.